today. And of course, today we're actually going to finish chapter 11. We call that analysis of categorical variables. We started this on Monday, and of course, we actually going to complete that today. Okay, so in the outline, I'm actually going to talk about I'll continue with the analysis of two variable association. And of course, going to show you how this can be implemented in R. Then from there, I'm going to talk about the measures of association. Okay, so let's go into business. Now, I've introduced you to analysis of categorical variable. This is just going to be, um, further example on the topic. And I'm going to use example that we use in class on Monday. Okay, the example 11.1. Okay, so the entrance polls from the 2012 Iowa Republican caucuses collected information from 1,787 caucus voters. So the survey data is summarized in the following contingency table, which breakdowns the number of votes for each candidate by family income level. Of course, as you can see in the table, the family income level is being cross-listed with candidates. So we got to categorical variables. The family income level has 3 levels. And of course, we got 4 candidates. And of course, the number in the cell from 94 to 130 actually represent the numbers of votes received by each candidate. Okay, putting into consideration the income level. I think I explained all of this in class on Monday. Now, let's say you're given this, you're given a contingency table like this. And of course, the question asked, there's going to be several questions asked. Name the two categorical variables in the study. Of course, it is family income level and candidates. Now, another major question is there an association, okay, between candidates and income level among the entire population of our Republican caucus voters? There's something I wanted to see here. This will require us testing hypothesis because we want to see whether there's an association between the two categorical variables. Association actually means, is there relationship between them? Can we in a way link our candidate preference to family income level? That's another way to put the question. Now, when you're given a question like this, how are you going to start? Okay, now because the whole thing actually starts with assumption, okay, and the only way to see whether the assumption is met is for us to calculate the expected count cell. The assumption is actually revolve around it has to be random variable. Not only that, the expected cell. Take a look at the assumptions here. The expected cell count all has to be greater than 5. How am I going to know if the expected cell count they are greater than 5? The only way to know is actually to go back and compute the expected cell count. Though initially you only have 94, you know, you have 94. If you take a look at this from 94 to 130, they are the observed cell count. For each of the observed cell count I show you in class on Wednesday, on Monday, on how you can calculate the expected cell count. So I'm going to show you as an example once again, if I want to get the expected cell count for 94, I'm going to look at the row total for 94. I'm going to look at the column total for 94. Okay, then I'm also going to look at the overall total. So if I want to get the expected cell for 94, it's going to be 590. Okay, multiply by 419. Okay, divided by 1787. So what I'm trying to say now, when you do that, you're actually going to get the expected cell count for 94, which is 138.3. So what I mean, if you do that, you're actually going to get the expected cell count that we talk about. So you're going to follow all of that, you'll be able to get the expected cell count for 112, for 183. You can see the values in the parentheses. They are the expected cell counts. The values that you were given initially were the observed cell count. Now, if you really want to know whether the assumption hold, what you're going to do, none of the values in the parentheses that will call the expected cell count should be less than 5. If you take a look at what we have right now, all the values in these parentheses, they are all greater than 5. Now, because they are all greater than 5, then we actually going to be celebrating, then we're going to say assumption hold. That is the only way we can investigate whether assumption hold. Don't forget, we got two assumption. They have talked about random samples, and not only that, the expected cell count all has to be greater than 5, which is what we have already investigated. Can I confirm again if everyone is still hearing me clearly? Is everyone still hearing me clearly? Can you confirm
Yeah, we can
again?
hear you just fine.
Okay, thank you so much. Thank you for confirming that. Now, after we have investigated assumptions, and in case if there is anyone who need clarification or you want to ask question, of course you can ask me question, okay? I want this to be like a regular in-person class. Okay, so the next thing is formulation of hypothesis. Of course, in the formulation of hypothesis, you're actually gonna write the HO and HA. The HO is always gonna be like now you say the two variables are independent. Independent means another way to write independent is that there is no association between them or there is no relationship between them. That's another way to put that. While the alternative is gonna be they are dependent. They are dependent actually means we got association between them. We got relationship between them. That's what it means. And after the hypothesis of formulation, the next that you're actually gonna talk about is the test statistic. And I need you to pay attention to the way I'm actually gonna get the test statistic right now. Okay, so if I want to get the test statistic, what I'm actually gonna do, I'm actually gonna come back here. Observe 94 minus expected 138.3. I'm gonna square it and I will divide by 138.3. I'm gonna do that across. Then I'm gonna add them up. Okay, that will give me the chi-square. That's exactly what I'm doing here. Take a look at that. You see, I subtracted expected cell count, okay, from the observed cell count. I square that. Then I divide by the expected. Okay, I'm going to do that for every one of them. Then I'm going to add them up. That will give me 103.85. Okay, the 103.85 now can be called a chi-square test statistic value. A chi-square test statistic value. That is how I got that. So which means the moment your expected is wrong, okay, that value is going to be wrong. Don't forget the chi-square measure discrepancy between the observed cell count and the expected cell count. And that was the reason why we're subtracting. And after subtraction, you're going to square it. You're always going to square them. And because it is called a chi-squared, a chi-squared, you square that, then you divide by the expected. Okay, that's exactly what we've done, what we're doing here. All the way, to 130. If you take a look, all the way to 130, we mean all the way here. Okay, we're going to repeat that for all of that. Okay, all the way here. And at the end of the day, we got a chi-square test statistic value. Now, after getting a chi-square test statistic value, the next is degree of freedom. The degree of freedom is actually the numbers of rows minus 1 multiplied by the numbers of columns minus 1. R represent the numbers of rows. C represent the numbers of columns. So if you go back to the question, okay, the numbers of rows is the numbers of levels, 1, 2, 3. Okay, the numbers of column here, numbers of level of the candidate, 1, 2, 3, 4. So I'm going to subtract this guy from 1, 3 minus 1, 4 minus 1, and I'm actually going to multiply them. Therefore, for this question now, the degree of freedom is 6. Okay, and after you're done with that, you're going to go to p-value. As for the p-value now, I actually want to figure out the probability of a chi-squared. Okay, the chi-square at the degree of freedom 6. This is I got the degree of freedom 6 right here, right? So you're gonna write the p-value is the probability of the chi-squared. Okay, at the degree of freedom 6 greater than the the test statistic value. And of course, if you want to do that now, I gave you the code on Monday. It's gonna be a p-chi-sq. You indicate, let me see. I think I'm gonna write that for you, so that you understand. You quickly recall. So it's gonna be if you write p-chi-sq, okay. If you write p-chi-sq, you can check your notes into okay 103 into 103, okay 0.85, okay comma, and you put the degree of freedom. Okay, the degree of freedom is 6. Okay, and you put the lower, the way we normally write it in class. Okay, the lower here is going to be equal to a false. Okay, that will automatically give you these results. And the moment you have that result, that result is very, very small. So what you're gonna do, because they ask you to test at a 0.05 level of significance. So because they want you to test at a 0.05, because if you go back to the question said at the 0.05 level, test for an association between one's family income and their candidate preference. So right now, the p-value is actually less than a 0.05 in your conclusion. You're actually going to reject H naught. And your conclusion now is that there is a significant association between family income and the candidate at the 0.05 level. And that's going to be the end of the test. So what you're trying to say now, association exists, relationship exists between family income level and the candidate preference. And this relationship, this association is significant. That's what you're trying to tell the world. Is there any question at this point? Okay, can you confirm again, if you can still hearing me clearly? Is everyone still hearing me clearly?
Yeah.
Thank you so much. Thank you for confirming that. Now, I want to walk you through how do we do this in R. For instance, if you want to program your entire data in R, okay, how are you going to achieve that? Actually, I want to walk you through the analysis of categorical variables in R. You know, in this class, we use an R software, right? How do we implement that? Now, well, you're given a different question now, 11.2, and the question asks, are smoking and divorce related? Okay, you want to know if you are looking at the effect of smoking on divorce, the divorce, whether you divorce or not, you want to look at the role played by smoking. Smoking is categorical, divorce is categorical. No, smoking is categorical because it's either you smoke or not. That's yes or no. Divorce is categorical. It's either you divorce or not. That's why you see yes or no. They both have two levels. Take a look at that. Now you are told here a random sample of 1,669 adults were interviewed about their marriage and smoking statuses. Now the question now here, use R to test for an association between smoking and divorce at the 0.01 level. Okay, don't forget what you're giving inside here. Okay, they actually expected. Oh, sorry, they are observed cell counts. 238, 247, 374, and 810. They are observed cell counts. Just wanted to take note of that. Okay, so if we want to do this in now, how do we program the data in now? I need you to pay attention right now, see the way I'm gonna figure it out. Now, if I want to if I want to put the data in matrix form, okay, what I'm actually gonna write, I'm gonna write that less than minus matrix. Then I'm gonna put this parenthesis column. I'm gonna put 238. Where is it coming from? 238, 247, 374, 810. Take a look at that. See the way I write it out. That's a way, that means I want to generate a matrix in R. And I'm going to tell R, okay, if I have these numbers now, okay, how many rows do I want? I have to tell R, this one means I need two rows. If you go back here, you're going to say we got 1, 2. That is two rows. 1, 2. Okay. And that was why I said n row equal to 2. Okay. I say by row equal to true. So you're gonna write that. The moment you write that in R, then by the time you write that and you click on enter, R will automatically generate this for you. So generating this for you now, it means your data is in matrix form. You need to first of us have your data in matrix form before you can actually implement analysis of categorical variables in R. And after that, the step two is now that you have your data set in, step two is to run the chi-square test. What you're going to do, you're going to say my test less than minus chi's dot test. Okay, you're always going to write this guy. Then your data, the name of your, that now represent the name of the matrix that you generated from the data. Okay, you're going to put correct equal to F. Correct equal to F. Oh my God. This is the arrow output now. Okay, the arrow output now is trying to tell you your chi-square test statistic value is 45.292. Okay, your degree of freedom is 1. Okay, let's see. Let's see whether degree of freedom is 1. Of course, it's going to be 1. 2 minus 1 times 2 minus 1. That will be 1 times 1. That's going to be 1. Okay, you can see the degree of freedom is 1. And the chi-square test statistic value, imagine if you want to get this guy out, you need to do the observed minus expected all squared divided by expected. You're going to do it for all of that. You sum it up before you be able to get that. But right now, R has automatically computed that within 1 second. And of course, look at the p-value. You got the p-value of the test. Take a look at that. So there's a lot of output in this. And the next is you're going to go back to your assumptions. You're going to go back to the step. Okay. In the step, you know, that is step number 1 on the expected cell count. Assumptions, you're gonna write the hypothesis. H naught, HA, smoking and divorce are independent. Smoking and divorce are dependent under the test statistic. All these guys, you need 2 things in the test statistic. You need the chi-square test statistic value and the degree of freedom. That's already computed for you using R. All what you just need to do is to write them out. Then after that, the p-value, right? The p-value, you're gonna write the p-value, you're gonna write the probability of the chi-square at 1 degree of freedom greater or equal to this guy. Okay, that's why you need 2 values in the test statistic in case you want to write the p-value. You can see here said the probability of a chi-squared at degree of freedom 1. The 1 is from here, greater or equal to this guy. Now is this, where do I get this now? This is from the p-value. This is from the arrow output. Look at that. That you already computed. You see that? Then now that this guy is less than 0, you compare this guy with the level of significance of a 0.01 given, and of course this guy is extremely small. If it is smaller than that, then you're actually gonna reject H naught. Of course, rejecting H naught, you said there's a significant association between smoking and divorce at the 0.01 level. So what you're telling the world is that smoking play a very huge role in divorce. That's what you mean. Because significant relationship exists between smoking and divorce. Is there any question before moving forward? Is there any question before moving forward? Can somebody confirm again if you can still hearing me clearly? Is everyone still hearing me clearly? Can somebody confirm that again if you can still hear me clearly?
Yeah. Yeah, we can still hear.
Okay, thank you so much. Thank you for confirming that. Now, the next subtopic for today is what we call measures of association. You know that in the last example that we did, We are only told that significant association exists, but we don't know the strengths of the association. And the only way to know the strengths of the association is actually to have a measure of association. So the test that we just conducted right now is only going to tell us whether relationship exists or not. It's not going to tell us the strengths of the association. Okay, if we want to know the strength of the association, what we're going to do now. Okay, what I mean, so what I mean is, if you want to know the strength of the association, we need the measure of association. And I want to welcome you to the measures of association. I said what we've done before. What a chi-square test does is to address whether or not an association between two categorical variables exists. So chi-squared, I just wanted to take notes. Chi-squared does not address the strengths of the association. Okay, and so if you want to if you want to understand the strength, the magnitude of the association, then what we need to do is to have a measures of association. And one of the measures of association is a risk. We need to measure risk. What do we mean by risk? Okay, the risk of an outcome is just the probability of its occurrence. What is the probability that an outcome is going to happen in a particular group or in a particular population or in a particular categorical variable? Then we can also talk about relative risk. By relative risk, I got two groups. Okay, I got a risk for each of the group, and I find the ratio. That's what we mean by relative risk. So one of the way to measure the strength of an association between two categorical variables is actually to compute relative risk. I'm going to say that again. Like I said, the chi-square test that we've conducted before only address whether or not an association exists between two categorical variables. But the weakness of a chi-square test is that it does not tell us the strength of the association. And the only way to measure the strength of the association between two categorical variables is actually, to compute the relative risk. Okay, relative risk means the ratio of the risk from the two groups. And I'm going to show you how to get the risk from each of the group. Okay, now I want to go back to the example that we just finished. And also I said, we previously showed that there is a significant association between the incidence of smoking and divorce. Okay, and what we want to do now, we want to describe this association. We want to know the strength of the association. Don't forget, we've taken a decision using a chi-square that significant association exists. But the issue with a chi-square is that we're not able to know the strength of that relationship. And that's exactly what we want to do now. Okay, now we're back on this data set. Now what we're going to do, I need you to pay attention now. I need you to pay attention now. Okay, don't forget, in the smokers group, don't forget, in the smokers group, we actually, we're focusing on yes here, right? We're focusing on yes. Okay, and we're also focusing on yes here, right? We're focusing on yes in smoke, yes in divorce. That's what we're focusing on, right? Now, if we're focusing on yes, you know what we're gonna do, what is the probability of smoking, okay, if you take a look at, give me 1 second, I want to measure risk right now, okay. Now, if you take a look at what I have here, what is the estimated risk of divorce among smokers? Okay, I'm going to say that again. What is the estimated risk of divorce among smokers? How do I say 238 divided by 85? Because take a look at this. 238, okay, is the number of people that smoke and they divorce. They divorce. That's why it is 238 now. Okay, divided by the totality of those who smoke. 485 is the totality of those who smoke. Okay, I'm going to tell you again, focusing on yes. Okay, yes, which is 238. And this is the totality of those who smoke. Okay, and that was how we got 238 divided by 485. Okay, so that was why we get here. 238 divided by 485, that would be 0.491. Now, this guy is the estimated risk of divorce among smokers. Okay, now, I focus on smokers. It is not only those who smoke that divorce their their partner. We also want to consider non-smokers group. Now, for non-smokers, we're gonna go back. For non-smokers, oh my God, we are actually focusing on no in the smokers, okay, and we're still focusing on yes in the divorce. In that situation, I'm actually gonna have 374 divided by the totality, okay. The so when you take a look at what I have, that was why I got 374 divided by 1184. Okay, I'm looking at the estimated risk of divorce among non-smokers. Okay, estimated risk of divorce among non, which means 374, okay, of those who do not smoke divorce their partner, 374. So if you want to get a risk, that would be 374 divided by the totality of those who do not smoke. Okay, that is how we get a risk, estimated risk for a particular class. Okay, and after we've gotten the estimated risk right now, okay, we got the estimated risk of divorce among our smokers. We also get the estimated risk of divorce among non-smokers. Then the next thing is to compute the relative risk because we need relative risk as a measure of association. If I really want to get the strength of the association, I'm actually need to compute relative risk. Now in C, relative risk right now, it's actually going to be what I got. Okay, for smokers divided by what I got for non-smokers. That is what I have here, and that gave me 1.554. Let me tell you this. If the ratio is, let's say I got the same, let's say what I got here is the same as what I got here. Relative risk equal to 1. If the relative risk is 1, okay, then it is equal. You're trying to say the risk is equal. Okay, whether somebody smoke or somebody did not smoke, the risk of divorce is going to be the same. That is if the ratio equal to 1. But right now, the ratio is greater than 1. Okay, when the ratio is greater than 1, the reason why we have greater than 1 is because the numerator is bigger. Look at that, numerator is bigger. So which means the risk is bigger among the smokers. That's what it means. Okay. It means the risk is smokers. I mean, the risk is actually big, is bigger among the smokers. And that's why if I want to interpret this guy now, I'm actually gonna say, based on this sample, we will estimate that those who smoke are about 1.55 times more likely to divorce than those that do not smoke. Okay? So that is how we actually figure out relative risk. And don't forget, this is going to give us a further information because what the chi-square test of association is going to give is whether a particular categorical variable can actually be linked to another categorical variable. But the chi-square test has a weakness. It's not going to address the strengths of the association. And that's the reason why we're trying to find relative risk. So relative risk will enable us to understand the strength of the association between the two categorical variables. Okay, so that's how to do it. Oh my God, what is next? Of course, this is going to be the last chapter in the semester after Thanksgiving. We're actually going to go to regression analysis. Of course, in the regression analysis, you'll be able to know how to investigate relationship between two quantitative variables. Okay, so is there any question before I go today? Is there any question? Okay, so before I go, I first want to appreciate everyone for attending my lectures on Zoom today. But I'm actually gonna say this before I go. Okay, somebody said, Professor, somebody said, okay, I think I'm gonna read the chat now. This one, since I have a lot of time left, I think I'm gonna read my chat. Okay, and somebody can also ask questions. Someone said I was wondering when the midterm two grade will come out. Okay, the midterm two grade I've already posted for the other section. The midterm two grade is likely gonna come out after Thanksgiving for this class. And let me also say this. I got a good news again. I'm also going to provide an opportunity to make up exam two. That is a good news. I've already provided an opportunity to make up for exam one. And exam one, the makeup that is currently on is going to be on until Friday. Okay, that makeup, and everyone is allowed to do it. Okay, you got nothing to lose. I'm only going to choose your higher score. I'm going to choose your higher score. I'll compare your previous score in the makeup, in the exam one, okay, with the makeup score. I'm actually going to retain the higher one at the end of the day. You got nothing to lose. So I'm also going to provide the opportunity for makeup too. Okay, but that will be announced later. Okay, you're gonna make up, like I said, you are making up for exam one. You're also gonna make up for exam two, but there is no makeup for the final. I just wanted to know that. Somebody said, I think I've answered that question now that I'm reading on the charts. Now somebody said, let me see, give me 1 second. Somebody said, um, for the makeup test, when you say open book, can we go back to our lecture slide? Of course, you can do that. You can use your lecture slide, you can use whatever, but the only thing you cannot do when you're taking the exam, you cannot search for clue online and you cannot communicate with your friend. You only need to log on to the Zoom with your video on. Okay, I believe I've answered that question. Somebody said, thank you so much for the makeup opportunity. I'm also going to thank you too for being a very good student. Somebody said I emailed you about adding extra credit to my grade. I'm not sure if you saw my email. Okay, now that I've provided a makeup opportunity, uh, I think I'm gonna wait until the makeup is already completed before I'm gonna start adding before I'm gonna honor the request. Okay, so sorry about that. I'm actually gonna wait for makeup to be completed. So after Friday, because the makeup is going to be completed on Friday. Somebody said, how exactly will Zoom work on makeup? We have a microphone on too, or just it's just going to be camera, okay? Because there's possibility that you log on to the Zoom and there's another student in the Zoom. Although you need to be muted because of the background noise. You need to be muted. You turn your video on and you need to be muted. I need to track your video. I need to track you. In case you want to go and use the bathroom, in case you want to go and use the bathroom, okay, in case you want to go and use the bathroom, you have to announce, you have to say it out. And I want to go and use the bathroom, okay? And then you go and use the bathroom. Somebody said, when will midterm two makeup come out? That will be after Thanksgiving. The moment you see your result, you'll be able to know whether you want to improve on it or not. So the announcement for midterm two makeup will be made after Thanksgiving. Somebody says, is there another practice exam for exam one makeup? No. Exam one makeup will test the area tested in exam one. There's not going to be a practice exam for that. Okay? So you only need to focus on what somebody said, is there a 60-minute time limit? No, it's 90. It's 90, not 60 minutes. It's 90. If you are talking about makeup one, makeup for exam one, it's actually 90. It's 90 minutes. Somebody says, so we can take it at any time of the day until 10 a.m. on Friday. Yes. By 10 a.m. on Friday, you are not going to have access to that again. It's going to disappear. Okay. And don't start by 10 a.m. on Friday. Don't start at 10 a.m. Make sure you do it before 10 a.m. on Friday. It's still open now. Okay, throughout today is open, throughout tomorrow is open until 10 a.m. on Friday. Okay, and you got nothing to lose. You got nothing to lose. Like I said, nothing to lose. Because I'm only going to use a better, I'm going to use a better score out of what you have before and what you're going to have in the makeup. And somebody said, with the midterm two have a 10-point curve like midterm one, that was why I'm providing the opportunity of makeup. Okay, also I'm providing the opportunity. Somebody say, if our notes are on iPad, can we use our iPad? Yes, yes. If you have your notes on the iPad, you can use your iPad. The only thing you cannot do is to search for Clio online. Okay, you can use, if your note is on the iPad, you can actually use that. Somebody says, the multiple choice for makeup one also 40 questions. No, it's 30, 30, 30 questions. Okay, it's 30 questions. I think I've answered all the chat. In case there's anyone who also want to ask question, I've already addressed all your concerns through the chat. So is there anyone who want to ask question before I go? Is there anyone? Like I said, on the makeup one, makeup for exam one, show your work. The moment you are done, okay, the moment you are done, you're going to see your results immediately. Immediately, you're going to see your results. You got nothing to lose. Like I said, everyone is encouraged to, to attempt makeup. Everyone is encouraged. Yeah, it is chapter one to chapter seven. The coverage of it's going to have the same coverage with exam one. So, or someone said, would there be any scratch paper for it? There's no any scratch paper. All we just need to do, maybe you need a paper to work it out before you choose, because everything will be done online. Okay, you're going to choose your core option online when you're done. Choose it online. Okay, maybe question one, A, you choose A, question two, C. Maybe you choose C after working it out. You don't need to see your work. Okay, So somebody says, so there's no call for exam two. Uh, whatever I'm going to do to exam two, will depends on the performance. You've not seen any result right now. But the only thing I can tell you right now, there's also going to be a makeup for exam two. Just like the way we got a makeup for exam one. There's going to be a makeup for exam two as well. Okay? So I think I've answered all the questions. Okay, so in the absence of other questions, I'm wishing you a successful Thanksgiving celebration. Make sure you all stay safe. I'm actually gonna see you next week, Monday. Bye for now, everyone.
Thank
Thank you too.